Today we are going to cover sections 2.2 and 2.3, transformations of functions. Be sure to write down your title and your essential question. How do you write equations and draw graphs for the simple transformations of a parent function? Go ahead and paste your cutout and copy example number 1, pause it, and we'll continue once you're ready. In this section, we're going to cover vertical and horizontal shifts. We're going to let C be a positive real number. Vertical and horizontal shifts in the graphs of y equals f of x are represented as follows. And you covered this back in Algebra 2, and you got an introduction in Algebra 1. We want to be able to find out what happens when there's a number after the function. So with a plus c or minus c. So that's going to create a vertical shift. It's going to move it up if it's positive, move it down if it's negative. And you guys covered this back in Algebra 2 when you guys covered equations such as y equals a x minus h squared plus k, where you looked at what does the value of a do to the graph, the value of h and k. So this is basically the same process, but now we're going to use more of the function notation. If we go into decimals, so at this point you should be able to do this yourselves through decimals. So just go into decimals.com. Then I'm going to click on graphing calculator. If I type in the parent function of a quadratic equation, y equals x to the power of 2, that is a parabola. What happens if I place y equals x squared and if I add a number plus 1 or plus 2 or plus 3? Or I can do minus 1, minus 2. So notice that if it's positive, it moves up. If it's negative, it moves down. Or we can just do plus c. And that will create a slider. You can add a slider. And if we add a number, plus, it moves up. Minus moves down. Up and down. So therefore, the value of, if the value is outside, if the number is outside, it's going to move it up or down. It's going to create a horizontal shift if the number is inside. If it's a negative, it's going to move it to the right. If it's a positive, it's going to move it to the left. So if you go into decimals, and now we're going to place the plus c inside the parentheses. And what happens if it's positive? It moves to the left. If it's negative, it moves to the right. So those are just horizontal and vertical shifts. In this case, positive moves it to the left, negative moves it to the right. So one of the things that I ask students to remember is that if it's outside, it's basically positive up, negative down. If it's inside the parentheses, it's going to be the opposite. If it's negative, moves it to the right. If it's positive, moves it to the left. So outside is basically the same. Inside is going to be the opposite. Negative moves the right, positive moves the left. So let's go through example number 1. Use the graph of f of x equals x to the third power to sketch the graph of each function. So they give you your parent graph, which is the basic graph of x to the third, and they want you to graph x to the third minus 3. So let's create a 5 by 5 graph. Make sure that you guys are using a ruler. So I'll do 2, 4, 5, 2, 4, 5. And I'll be doing this 5 and 5. And let me do one for the other one as well. We have 2, 4, 5, 2, 4, 5. And now, first we are going to graph your parent graph, x to the third power. So what does the x to the third power looks like? Correct, it will be 1, 2, 3. So first, plug in a 0 gives you 0. Plug in a 1, 1 to the third power is 1. Plug in a 2, 2 to the third power will be 8. 2, 4, 6, 7, 8. Plug in a 3 will be 27, too high. Plug in a negative 1 gives you a negative 1. Plug in a negative 2 to the third power will be negative 8. 2, 4, 6, 8. So therefore, this is my parent graph. So now you need to think, okay, what is the negative 3 going to do to the graph? It's going to move it down 3. Now ideally, we should be able to move the entire graph. If I have my graph, ideally I should just move it 1, 2, 3. But because we're not able to move the entire graph at the same all at once, we're just going to draw each point down 3. This point gets down 3. This point 1, 2, 3. And this point 1, 2, 3. And now we are going to sketch our g of x. And we're going to highlight the parent function in yellow. Let me highlight my g of x. We are going to highlight in orange. Let's go and label it. This one is f of x, and this one is g of x. One more thing that we can do is that we can express g of x in terms of f of x. So we have g of x is going to be equal f of x minus 3. And we'll come back to this notation throughout the notes and on the last few examples. So that's another way to be able to represent g of x. Letter B. Let's go and sketch our parent graph first. We have 1 point here, 1 point here, and 2, 4, 6, 8. 1 point here, and 2, 4, 6, 8. This is our parent graph, f of x. So now graph h of x. And what does the negative 3 do to the graph? And what does the 2 do to the graph? Go ahead and graph it, pause it, graph it, and then we can check our answers. Pause it. Excellent. So in this case, this negative 3 is going to move the graph to the right, and this positive 2 is going to move it up. So therefore, each point will move it to the right 1, 2, 3, and 1, 2. This point will be 1, 2, 3, and up 2. This point 1, 2, 3, and up 2. This point here 1, 2, 3, and up 2. This point here 1, 2, 3, and up 2. Now I'm just going to sketch it. And let me go and highlight it. In this case, I'm going to keep it as green. I'm all labeled, so this is my f of x function. This is my g of x function. And once again, we can rewrite h of x in terms of f of x, we're doing the following. So we have h of x is going to be equals f instead of x will be x minus 3 and plus 2. So that's another way to be able to write down h of x in terms of f of x. And notice that it's very similar. The minus 3 goes inside, the plus 2 goes outside. Example number 2. Go ahead and copy the cutout or paste it, and we'll continue once you're ready. And example number 2. Go and pause it. So reflections in the coordinate axis. So reflections in the coordinate axis, the x and y axis of the graph y equals f of x, are represented as follows. So we have a reflection in the x-axis. That is, if you have a negative on the front, we know that's going to be reflected on the x-axis. If you replace the x with a negative x, it's going to be a reflection on the y-axis. So compare the graph of each function with the graph of f of x equals the square root of x minus 1. So let's go and make a quick graph. Let's do a 5 by 5. 2, 4, 5. 2, 4, 5. And let's do the same thing for the second graph, for the second problem. So now the question is, how do you graph this? What does it look like? So at this point, you should be able to know that the graph looks something like this, correct? Now, what if this is the parent graph, f of x equals the square root of x, what does the negative 1 do to the graph? You'll shift it to the right one spot. So it used to be here, so now it's going to be moved to the right. The next point, if you just use f of x, if we just graph f of x equals the square root of x, if I plug in a 0, it gives me 0, but then moves to the right one. If I plug in a 1, it gives me 1, but I'll be moving to the right one. And the next point or value to plug in will be a 4. Plug in a 4, square root of 4 is 2. 4 is 2, but we'll be moving it to the right one. Now this will be my function. So that is f of x. What does the negative do to the graph? So the negative is going to be a reflection on the x-axis. So you want to think about this being the y values. So with the negative, it's basically going to make all the y values the opposite. So in this case, the opposite of 0 is 0. The opposite of 1 will be negative 1, and 2 will be negative 2. So that's how the reflection on the x-axis. This is going to do the same thing. Let's go and highlight it. Let's go and label it. This is my f of x, and this is my g of x. And we can also write down my g of x in terms of f of x. The only difference is a minus in between, so therefore will be g of x equals, what will that be? It'll be negative f of x. And if we go into decimals and we just type in let's go and type in the parent or the f of x function. To type in square root, you can click on the little keyboard and the square root is here. Or I prefer, instead, I can type in sqrt, it converts into square root, x minus 1. Let me change the color to blue. And now I'm going to type in g of x equals negative square root of x minus 1. And notice that, let me change that to red. So therefore, another way to write down, if I want to write down h of x equals negative f of x, and let me just place as purple, you notice that is the same way to end up with g of x. Both of them are the same. And both of them are a reflection on the x-axis. So now, let's graph the f of x function. This is one here, and 1, 2, 3, 4, up to. And I'm going to highlight it as in yellow. Now, what does the negative do to the graph? That's going to be a reflection on the y-axis. So basically, all the y values will become the opposite. So this is a positive 1 becomes negative 1. This is a positive 2 becomes negative 2. This is 1, 2, 3, 4, 5, 2, 4, 5. And that will be my graph. Let me highlight it in green. Let me label it. This is f of x. This is h of x. And now I can rewrite h of x in terms of f of x. So g of x, h of x. H of x equals, and we'll basically just replace that x with a negative x, so it'll be f of negative x. So that's another way to write down h of x. Example number 3. Go ahead and paste your cutout. Copy example number 3, and we'll start once you're ready. Go ahead and pause it. In this case, we are covering non-rigid transformations. So non-rigid transformations are those that cause a distortion, a change in the shape of the original graph. So we are going to have a vertical stretch and a vertical shrink. Sometimes before they use the word wider or narrower, we prefer to do a vertical stretch. And if we go into decimals, let's actually go back to the last example. Notice that if we place a negative in here, that reflects it on the y-axis. Right, so that's a reflection on the y-axis for the last example number 2b. But now let's go into decimals and type in just a function f of x, or just f of x equals x to the power of 2. And what we want to do, I want to make this blue on the next line. Let's just call that g of x. And if I type in a 2x to the power of 2, and let me put this as red. So if this is a 2 or a 3 or a 4 or a 5, or let's just place a, or in this case c. Now we want it to be from, we don't want it to be negative. So therefore I'll click on these little numbers, on this little 10, and this comes up. So I'll place it from 0 to 10, that's going to restrict those values. And let's make it to 5. So if it's 1, it's the same. If it's bigger than 1, it's going to be a vertical stretch. If it's smaller than 1, it's going to be a vertical shrink. Now, if the value of C is greater than 1, it's going to be a vertical stretch. If the value of C is between 0 and 1, it's going to be a vertical shrink. So if it's smaller than 1, it's shrink. Bigger than 1, stretch. Now, for horizontal stretch and horizontal shrink, the number will be inside, right next to the x, inside the parentheses, inside the square root. Now, if the value of C is between 0 and 1, that's going to be a stretch. If the value of C is greater than 1, it's going to be a shrink. Remember the one we talked about. If inside is going to be the same, positive up, negative down, if it's outside. If it's inside, it's going to be the opposite. If it's negative, to the right, positive to the left. The same way it works in this part. If it's smaller than 1, it's going to be stretch because it's going to be the opposite. And if it's bigger than 1, it's going to be a shrink. If we go back into decimals, and I'm going to place this C inside the parentheses. That's how it should be. And let's make that into a 1. 1 is the same. If it's bigger than 1, it's going to be a horizontal shrink. So you kind of have to think about that it's shrinking. It's kind of hard to see, especially with a parabola. If it's smaller than 1, it's going to be a horizontal stretch. So you have to think about stretching and horizontal, like just pulling it. That's a horizontal stretch. Now it's hard to see with the x squared or x to the third, but if we actually graph sine of x, that will be much easier to see. Fucking type in sine of x, and I want to place a c on the front. Now actually, let me just place a c outside. Notice that if it's smaller, it's a vertical shrink. Bigger, you can see a vertical stretch. That you can see. Now, if I place my c inside, and I place this into a 1, 1 is the same. If it's smaller, it's going to be a stretch. And you can see a stretching. Visualize it. Compare the graph of each function with the graph of f of x equals x absolute value of x, which is your parent graph, the most basic graph of an absolute value. And I need to be able to graph g of x, which is equal to 3 absolute value of x. So let's make it 5 by 5. 2, 4, 5. And what is the 3 going to do to the graph? That should be the 3 is going to be a vertical stretch. So it's going to stretch it by 3. So let's go and graph a basic graph, absolute value. Plugging in 0 gives me 0, plugging in 1 gives me 1, plugging in 2 gives me 2, 3, 4, 5. Plugging in negative 1 makes it positive 1, and so on. And now g of x, so this is f of x. So the 3 is going to multiply the y values by 3. So therefore, this y value is 1 is now going to be 3. this y value is 2 is going to be 4, 6. This y value is 3 will be times 3, 6, 9. Same thing here. 1 multiplied by 3, 2 multiplied by 3, 3 multiplied by 3 gives you 9. So that'll be your new graph, which will be g of x. I'm going to highlight it. This will be f of x, and this will be g of x. Now we can also express g of x in terms of f of x. So how will that look like? That'll be g of x will be equal to 3 f of x. Letter B. Let's make a 5 by 5 graph. And now I'm going to graph my parent graph of the absolute value 0, 1, 2, 3. I'm going to highlight it in yellow. And now I need to think, what is the 1/2 going to do to the graph? It's going to be a horizontal stretch. So this is a horizontal stretch. Where this was a vertical stretch. So how does that work? That means that this is going to be stretched by a factor of 1/2. So instead of being 1, it'll be 2. This, the x value is 2, now it's going to be 4. It's going to be stretched out by a factor of 1/2. 3, this will be 6. And same thing on this side. That's -1 becomes -2. This is -2 becomes -4. This is -3 becomes -6, and so on. So this will be our new function. And we are going to label it, and we'll talk about a bit more on this f of x, this is g of x. So one of the things that the way that you can think about it is that if you plug in a 2 into this function, this is 2 times 1/2 is 1. So that value will be the same as if you plugged in a 1 for this function. So that's why this point, it was this point here. If you plug in a 2, if you plug in a 4 for the g function, or this should be an h function. If you plug in a 4 for the h function, it'll be 1/2 times 4 will be 2. So it'll be the same thing if I plugged in a 2 for this function here. So that's why this point corresponds to this one. Once we go into the sine and cosine graphs, it'll be easier to visualize it. So now for now, h of x is equal to, how can we write down in terms of f of x? It'll be f of 1/2 x. And in this case, I highlight purple, orange. Example number 4. Describe the sequence of transformations from f of x to g of x. Go ahead and copy it down, and we'll start once you're ready. Excellent. So we have f of x and g of x. So this is a parent graph. So how many different translations and transformations do we have? Think about it and see how many do we have? 1, 2, 3, 4, 5, 6. We have 4. 1 for the negative. There'll be a reflection on the x-axis. The 2 will be a vertical stretch. The 1 is going to shift the graph to the left, and the negative 3 will be shifting it down 3. So let's write that down. The first one will be a vertical reflection on the x-axis, or just a reflection on x-axis. The 2 is going to be a vertical stretch by a factor of 2. The 1 is going to be shifts by 1 unit, or shifts left by 1 unit. And the last one will be shifts down by 3 units. Now do the same thing for letter B. How many different translations and transformations do we have? 1, 2, 3, or 4? Think about it. Go and pause it. You got it? How many do we have? We also have 4. 1 the negative, that's going to be a reflection on the x-axis. The 1/2 will be a vertical shrink. The 3 is going to be a horizontal shrink again. Remember, that's the opposite. If you notice a 3 bigger than 1, it's going to be a shrink. And the negative 4 is going to be shifted down 4. So let's write them down. Reflection on the x-axis. Then it is going to be a vertical shrink. By a factor of 1/2. It will be a horizontal shrink by a factor of 3. So even though it's going to be a shrink, we also say a factor of 3. And the last one will be shifts down 4. So this will conclude part 1. We'll continue with part 2 next time. Have a good day and see you next time.